Assalamu alaikum. My name is Sabir and I'm a student of Mechatronics and Control Engineering from University of Engineering and Technology, Lahore, West campus. I'm here to introduce my final year research project. The title of my final year project was Development of Low-Cost Portable Optical Motion Capture System for the Objective Measurement of Gross Motor Movements. We named the system as BIGKAT. BIGKAT stands for Boxed Infrared Gross Kinematic Assessment Tool. As the name suggests, the system can be used as a data acquisition system for recording the kinematic data where it can be used, such as gaming, robotics, biomedical, and sports industry. The BIGKAT consists on two parts, BIGKAT hardware and BIGKAT software. The BIGKAT hardware is a system consists three single board computers known as Raspberry Pis and three no IR cameras known as Raspberry Pi no IR camera modules version 2.1. And that is used to record the video of the participant, and then the single board computers process the video in online processing. We have designed a software for the processing. Let's move on to the BIGKAT hardware, then we will see on the computer screen about the BIGKAT software. That can be seen on the screen. The BIGKAT is fixed on a camera tripod. Each grey colored box is actually a Raspberry Pi and a camera module. These are actually Raspberry Pi cases, and the cameras are enclosed in them. All these Raspberry Pi can communicate to each other with these blue colored wires. This is the HMI of the BIGKAT, and it can also be controlled through touchscreen or through your laptop, as we're controlling it now from our laptop. It can be seen that the cameras are live, the camera channels are opened, and all the cameras can be seen in these small screens shown in the software. The software part is also covered in the following video. Now let's see what the BIGKAT can do. These are actually active IR markers. These markers can be attached on our body or on the body of the participant to record the motion, to record the kinematics data of the participant. These IR markers can be seen through, these are just LEDs known as IREDs or infrared LEDs. Now let's move on to the computer screen and see how to operate the BIGKAT and what it can do. The BIGKAT software can be seen on your screen. This is the first window that will appear after starting the software in the Raspberry Pi. This is the demographics window. We have to enter the demographics of the patient before recording the data. The ID is a must and all other demographics are optional. These options are used to tell the BIGKAT how to execute the program. The markers the time means that obviously the length of the video. The markers mean that the number of IREDs attached on the body, and the condition can also be mentioned, just like we are performing reach to grasp movement or finger tapping, so the condition can be mentioned accordingly. It can be any alphanumeric key. We can also load a pre-made participants list by clicking on the data control and load participant list. We have a participant list. The format of the participant list can be like that. This must be a CSV file, and we named it as calibration test leds.csv. The name is not necessary to match with this name, but it has to be a CSV file, and the format of the CSV should be like this. First of all, we have to enter the ID of the participant, then the forename, surname, date of birth, gender, recordings, number of markers, condition, and run. This run key indicates that the participant having the run key as 1 has already been processed, and there is no need to reprocess that participant. So that BIGKAT can know, do it have to process the participant again or not. Let's load the participant list and see how it can work. Let's enter the ID of the participant 1, this calib 1, and click on verify. It will load all the data of the calib 1 participant, and then we can click on the next. After selecting the saving directory, we can start recording. As you can see, it is running on a Windows computer, not on the Raspberry Pi, so we cannot see the recordings of the cameras. But if it was running on the Raspberry Pis, then we must have, and then we can see the Raspberry Pi cameras by clicking on the Start Preview button. Now we can click on Start Recording, and the cameras will and the Raspberry Pi will start recording the video of the participant having IR marker attached on the body for these seconds of time. The videos will be saved in this specific location, that can be given to the BIGKAT by selecting a recorded data folder or a USB drive that can be attached with the Raspberry Pi. After that, after recording the data, the recorded data will be in this form. We'll have videos of the participant, we'll have calibration files. There are actually 6 calibration files, 1 for each camera and 3 for stereo triangulation or stereo calibration, a file for demographics, timestamps of each video file. Let's see what is in the video. In this video, we can see the 3 iRads attached on the body of the participant, and the participant is performing reach to grasp movement. This is the client camera or the master camera. The slave cameras can also be seen in one of these cameras, in one of these files. The slave cameras can also be seen in one of these files. This is for the right camera and this is for the left slave camera or server camera. This data can be processed through BIGKAT software online on Raspberry Pis or on a desktop PC. The desktop PC is mostly recommended for the data processing because it is obviously fast than the single board computers. Now let's process the data. The data can be processed by clicking on the data processing, process data. After that, we have to load the data directory, and the data directory is this directory itself. Click on select directory, select folder, and now we can process the record 0 data. That is the test 4 patient. This test 4 patient. Let's process this data and see what we can achieve or what we can get. The data is being processing. By the way, multiple data can also be processed by clicking on each of them. The data processing needs some time as it is a time-consuming mathematical machine learning process, so it will need some time. 7% of the frames are missing from the data, but that's okay. Now let's see what we got after processing the data. It was the test 4 patient, the record 0 data, and we got all these files. All these files are actually the 3D coordinates of each of IR markers. And then all these parameters are necessary for the or can be used in the kinematic results of the participant. That is it from my side. Thank you so much.